Okay, continuing on the practice test, it says a sporting goods sells two types of tennis shoes. 240 pair of tennis shoes were sold. One style cost $66.95, the other $84.95, and the total receipts were $17,652. Write out the system of equations and tell how many of each were sold. Don't know how many of the $66.95 were sold, so call that X. Don't know how many of these were sold, so call that Y. But we do know that X plus Y equals the total amount sold, which is 240. Plus, if you take $66.95 times X, the number of $66.95 shoes that were sold, plus $84.95 times the number of shoes sold for $84.95 will give you the total revenue. That gives you this system of equations here, that X plus Y equals 240, and $66.95X plus $84.95Y equals $17,652. And just put those into this linear sheet right here, and you'll get this answer. On the next problem, problem 6, company sells three types of products for $20, $10, and $5. Total revenue is $350,000, which corresponds to the sale of 32,500 units. And from that, so far, we don't know how many of $20 units sold, or $10 units, or $5 units. So we call that X, Y, and Z. So X, Y, and Z have to add up to 32,500. And 20X plus 10Y plus 5Z has to add up to 350,000. That gives you two of the three equations you need. The third one comes from the fact that the company sold half as many units of the $20 product as the $10 product. That gives you this equation right here. The $20 product was X and the $10 product was Y, and you put the 0.5 or the 1/2 next to the Y. Like, for example, if Y was 100, 0.5 times 100 is 50. 50 of the $20 product. So this is the equation. Now we just have to get that equation in standard form. In other words, move the 0.5 over to the left, and that would be X minus 0.5Y. We have no Z's up here, equals 0. When we take the 0.5Y to the other side, we'd have 0. So pulling these coefficients off these equations and putting them into this three equations, three unknowns, you'd have 1, 1, 1, 32,500, 20, 10, 5, 350,000, and 1, negative 0.500. And you'll get these answers right here, and that means 7,500 or 7,500 of the $20 product, 15,000 of the 10, and 10,000 of the $5 product. On example or problem number 7, it gives you information about professional athletes and a matrix for their bonuses and a dollar amount for each bonus. And we did a problem very similar to this on the in the matrices area. So I put in their each player A, B, and C, their number of sacks, interceptions, and key tackles. Sacks, interceptions, and key tackles, and their dollar value for sacks, interceptions, and key tackles here, and we get the bonus for player A, B, and C right here. On now we're into some review problems that are it's a cumulative final, so some problems come from earlier sections. So jumping back to chapter 1 here, it says look for a linear relationship between the age and a person's driving test score. So I put those data points into the Excel sheet and the linear page. Clear back here to the linear page. I put those data points in. I got this curve of best, or this line of best fit right here. The slope is 1.109, and that means for each year your driving test score increases by 1.109 points. And let's see what else it wanted to know. So we answered that. The quadratic equation of best fit, let's get that. First of all, let me say what the y-intercept means. The y-intercept is 0, 36, which means at year 0, which is when you're born, your driving test score would be a 36. That's what that means. And here's your coefficient determination. Here's your R value, which is your correlation coefficient, so it's a strong positive relationship. We also were told to get the quadratic equation of best fit, so I copied these values already and put them into the quadratic page, and I got this quadratic equation of best fit. This minimum value right here tells me the age of a person, or sorry, this maximum, this is a maximum, and so the X value tells you the age of a person when they get their highest driving test score. So a 43.2-year-old will get the highest driving test score, and this tells you the score of that person, 85.77. So according to this model, when somebody is 43 years old, they will get a driving test score of 85.77. And it also asks what's the driving test score for somebody who's 55, or according to this model, just put a 55 in here and you get 78.9. And it also asks what driving test what ages do you need to be to get a driving test score of 70? Well, driving test score is again a y value, so put 70 in for y and you get these two ages, 25.5 and 61.1 are the answers to that. And that answers all the questions from problem 8, and we'll pick up from problem 9 on the next video.